Forward to another engaging day filled with academic excellence. We now begin session 2 under the chairmanship of Gulab Chand Arya sir. Dr. Gulab Chand Arya is currently working as a Ramalinga Swamy Re-Entry Fellows at School of Biotechnology, KIT University, Bhubaneswar. Prior to this role, he worked as a postdoctoral fellow at ARO Israel at the Department of Plant Science with a research and academic career spanning over 8 years. His expertise lies in the field of plant surface pathogen interaction, plant G protein signaling. Dr. Arya's research efforts have yielded sustainable outcomes, resulting in the publication over 19 research articles in reputable journals, along with paper presentation in over 10 national and international conferences and contribution to 3 book chapters. Dr. Arya is lifetime member of prominent organizations including the Indian Society of Plant Physiology. His contributions have been recognized through notable awards. The DBT awarded him the Ramalinga Swamy Re-Entry Fellowship Award. Now, I would like to request Dr. Shilpa Sharma, Dean Science, to welcome our session chair, Dr. Gulab Chand Arya sir. Wel- Welcome with a bouquet as a token of gratitude. With due permission, sir, can we start the program? Now I hand over the mic to Miss Monica, ma'am. गुलाब चंद आ गया
Good morning,
है
everyone.
ना
As
नेक्स्ट
Dr.
वाला
Monica said, Fashion Designing Department. And now I would like to invite Dr. Shilpa Sharma, Science, to welcome our speakers, Dr. G. Jagannath Rao, sir,
निकाल
to welcome with a bouquet as a token of gratitude. Now Ayushi will take over the mic for the introduction part. Thank you so much. Good morning, everyone. I am Ayushi Verma from the Department of Forensic Science. And I am Vedita Sahu from the Department of Biotechnology. And we are here to introduce the invited speakers at INCON 26. To kick off second day, I introduce our first invited speaker, Dr. GVP Jagannath Rao sir, who has published 8 books, 3 book chapters, 15 conference presentations, and 5 research papers in reputed international journals. He has successfully guided 7 PhD scholars. He has also organized national and international conferences. With an innovative and student-centered approach to teaching, he is committed to fostering an engaging learning environment and promoting academic excellence. A dedicated and focused academic committed to adding value through strong subject expertise and a continuous learning mindset, known for well-developed communication skills and a reputation for unwavering accuracy, credibility, and integrity. So, I request Dr. GVV Jagannath Rao sir to come on stage to share his presentation with us.
Thank you. Yeah, sufficient. Is it sufficient now? Am I audible? Hmm. Okay, check it. So pocket में रख दीजिए. Hmm. हेलो. अच्छा, इसमें लेना. हेलो. 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 Is it audible, sir? Mic. Hmm. It is looking little bit awkward. I will take this one. It's better. It is on, na, sir? Okay. Honorable Chairman, sir, Chancellor, sir, as well as the respected Vice Chancellor, sir, Ramarao, sir, and Register, as well as Director, sir, Naran, sir, and Dean of Science, and IQC Director, Ramesh Kumar, sir, and all the organizing team, esteemed team, those who are presented and organizing this conference. I want to thankful for inviting me to this prestigious international conference to deliver a talk on business plan and sustainability development. Nowadays, sustainability development is playing a major role in our society throughout the world, not only in our society. Our, if we discuss for sustainability, PPT, sir, what is sustainability development? So it is in long run and a long stability of a business. So it is a key to entrepreneurial success. If any entrepreneur is getting success in the sense because of their product quality. Now, in February 2024, our Prime Minister launched Surya Ghar Yojana. It is a solar energy system. It is also a renewable energy and sustainable long duration. Its period is they are providing 15 to 20 years of life. अच्छा मेल में सेंड कर. Sir, PPT. Please. Next one also you will download. Download it. Next. In that two videos also there. Next, this one. Shall I download? Next. लंबा है ना बेनिफिट लेना तो वो तीनों ये कि मैं रखना है
जी जी
एक फोल्डर में डालेंगे तो ये तीनों
दो वीडियो रही है ना
हाँ go down. Okay. Hello. So, business plan for sustainable development. Nowadays, government is also encouraging for entrepreneurship. In this, if you plan for the sustainable development project, then you will get long run benefit. Right? Nowadays, people, they are not looking for the quality, the cost. They are looking for the quality. They need best quality. So I have chosen this topic. It is a key for entrepreneurial success. In today's dynamic and highly competitive business environment, the integration of comprehensive business planning and innovative marketing strategies significantly enhances an entrepreneur's ability to survive, adapt, and thrive the business. So now, in recently, some of my students also, they are this Suryagar Yojana, PM Suryagar Yojana. Maximum students are getting benefit. They are started this initiative. Government said they are providing 1,08,000, and if you want to install for 3 megawatts, it is 1,80,000 only. So in this, out of 1,80,000, 1,08,000 government providing the subsidy, right? So maximum our Chhattisgarh people, household people, they are utilizing it and they are getting the benefit, so that our solar energy, we are not wasting. We are utilizing our solar energy. By using solar energy, we are generating the electricity. Next. Mastering both business planning and marketing strategy development is essential for achieving the long-term entrepreneurial success and organizational sustainability. So this is the running matter. It provides the direction and clarity, enabling entrepreneurs to anticipate potential challenges, manage risks, allocate risks, as well as allocation of resources is a major difficulty in any organization. So proper allocation is very important. Employability equality, employee satisfaction, job satisfaction, these are all plays a major role. If you are establishing any organization or if you are establishing any entrepreneur, small scale industry or large scale industry, then employee satisfaction plays a major role, right? Product or service should solve a real problem without harming the environment. Nowadays, why government is supporting this solar energy means it is as well as e-vehicles, electric vehicles. Why government is supporting subsidies and all in the sense it is reducing the pollution, air pollution, noise pollution. If you use the four-wheeler, it will give lot of noise. If you use the same vehicle, electric vehicle for four-wheeler, it will reduce the noise pollution, air pollution, and lot of energy saving also. Here I have showing one video for regarding the sustainability. Next era is the best energy, solar energy. They are wind as well as sir वो वीडियो प्ले अच्छा उधर ही है नो नहीं आ रहा
डाउनलोड मतलब डाउनलोड में जाएगा ना
Where is it? One second. Okay.
मेल वाले में चला जाएगा
Okay. No, it is there.
अरे इसमें जीवन पे डाउनलोड जाके निकालना ना
Take,
इसमें बाद में की
take. Right. एक बार बैक कर 1 सेकंड नहीं इधर इधर इसे क्लिक करने से हो सकता है इसमें टच करने से
हो रहा है अरे वीडियो
ये इसका टच करने से वीडियो आना है पीपीटी में आता है ना चलिए इधर इधर देखा हूँ और उसमें देखिए डाउनलोड्स में जाइए इधर में देखा हूँ
वीडियो बाद में करना
चलिए leave it. Yes, sustainable. No, it is a PDF.
वो है
No. Continue. We will continue. जीमेल में भी वहां डाउनलोड करके रखा हम लोग yes, we can. Yes. Okay. So here, only the main theme I have provided in words in next coming to the business plan. How you will plan now future entrepreneurs, right? Our students are future entrepreneurs. How you have to plan? Before planning, what you have to think? What are the major key points you have to identify and how you have to note down and how you have to implement that points. After that, you have to plan for your business. First, mission of the statement, operations, company background, product description, marketing plan, SWOT analysis, financial planning, as well as competition analysis. Means competitors. Nowadays, every product have a competitor, right? So competitor analysis and executive summary. All these things first you have to identify and you have to study. This is a ground level work. We are not started the business. Before starting the business, we have to do all these works at ground level. Then we have to think for our business, whether we have to move towards that business or we have to switch to other business, right? Even government is also for small scale industries, they are providing loans for BTech students. They are providing around 20 lakhs loan, right? For any graduation students, they are providing up to 5 to 8 lakhs loan without repayment, is very long tenure and a low interest rate. The key points here, the brief overview of the business, mission and vision of the statements, objectives and goals, sustainability impact, as well as risk analysis, growth strategy, and conclusion. These are all the key points only I am discussing here due to time framing. So market analysis. How do you study the market analysis? What is the market size? Where you have to launch the product? Whether that area is a fixed suitable to your product or not. All those things you have to study. Then only you have to go for market size and growth potential. Amul, best example I will give you. Amul, it is only started with one village. Later on, he started, why not I have to expand my business? Now, one of the largest milk producer in our India, Amul product, right? As well as if you think for our politician, Narendra Modi ji, right? He very low background person, but slowly and slowly he reached in the topmost position, number one person in our India as a prime minister. So many examples are there. IKEA. IKEA, have you heard? In our Raipur also, they are planning to launch IKEA store. It is major cities, they are launched it, right? It is only a store, pen store. Now they developed as the best market seller. And DMart. Before DMart, everyone knows only the big bazaar. इससे सस्ता कहाँ मिलता है, right? इसी कोटेशन से वो लोग स्टार्ट किया है. But at that time, DMart has not demotivated or demoralized. They started their business with innovatively. They attracted the house with household groceries. Now everywhere DMart, right? If anything, if we are thinking means we need to think for the marketing strategy and how to implement and how to reach our product to the customers, targeted customers. Here, one example, it is a next era. This is a wind energy systems, how they planned, how it is for sustainability development. If I'll only talking means it will give us a little bit more audio, sir.
Water should be able to stay stable. We call that equilibrium. It's not that you're not using any resources, you are, but you're doing it. It's a sustainable. What is sustainable? One of the more common definitions of sustainability used worldwide is from the UN Environment Convention. It's a sustainable development. It's development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So put simply, sustainability is about our kids and our grandkids. How do we live today so that they can thrive? Future generations can also have a good life. Our planet has many resources that we depend on for food, for housing, and many of those resources can be replenished. You can cut down a tree and grow new trees. You can catch fish and there will be more fish.
But that only works if you do it at a rate that these systems can replenish. We call that the replacement rate. You can think of it as a bathtub, and you're draining the bathtub and filling the bathtub at the same rate. And if you do that, then the level of the water should be able to stay stable. We call that equilibrium. It's not that you're not using any resources, you are, but you're doing it at a rate that the systems are able to stay somewhat steady. Right now, and over the past few decades, what we're seeing is that we are consuming resources much faster than the replacement rate. And the result of that, draining the bathtub faster than filling it, is that those levels are going down. We're seeing fisheries disappearing and other ocean life. We're seeing forests disappearing. Of course, everyone's familiar with the impacts of climate change and other impacts of this level of consumption, plastics in the ocean, all of these problems. So ultimately, sustainability is about understanding how all this is connected, understanding that when you make a decision to buy a smartphone, you are impacting someone's life on the other side of the planet who's involved in mining the materials to put in that smartphone. So sustainability is about systems thinking. One of the other big frameworks that we use to talk about sustainability is the 3 E's. In business, we call that the triple bottom line. Some people call it the 3 legs of the stool. And that's environment, economy, and equity. And it's not just about understanding that we need to manage all of those. It's understanding how they're connected. So if you only look at short-term economic profit, then you're not going to end up with a thriving economy in the long term. If you're only looking at conserving the environment without thinking about economics and understanding, how people are making their livelihood, you also may not end up with a thriving society. And if you aren't looking at equity, you're going to end up with a few people that have most of the resources and many people who are hungry and not living a good life. And that's not really a successful human society either. So sustainability is really about addressing all of those and understanding the connections between them. What is sustainability? One of the more common definitions of sustainability used worldwide is from the UN Brundtland Commission. They say sustainable development is development that meets the needs of the present without compromising the ability of future generations.
So I want to show this video here. What is the sustainability? Without harming the environment, we have to innovate and we have to think our product. Then only government also gives subsidy, permission and everything. And also you will not get the objection from your surrounding people. Market size and growth potential. How we have to expand our business, right? That is plays a major role. So if you are limited to only one particular pond in the sense, it is not growth of your business. You have to expand, right? Target audience analysis. Who are the major, entire world is looking towards our India. Why? Because India is a hub for the marketing. Our population is around 150 crore. As compared to other countries, our Indian middle class population buying capacity is more. If quality worthy, then they are ready to buy, right? Next, competitor analysis, market trends and insights. Product and service offerings. So, if we purchase any product, first we will think what they're servicing, whether they are providing the service with facility or not. In so many local products, if they are not unable to provide the service, right? Service provider is not available, then we will not choose such products. So we will go for brands. LG, if you take, it is an assembling of other company manufactured items. They are using their logo as a LG. As well as Tata in solar energy. Tata is purchasing from other companies, just they are assembling with their brand name. But they are the good service provider. That's why we will use Tata as well as Voltas, as well as this LG, whatever it may be, Godrej, right? And coming to future and benefits, whatever product you are planning or launching, its future, how much it will sustain, right? Long duration or short duration. Clear? And what are the benefits? You have to provide unique benefits as compared to your competitor and unique selling proposition. So different people will use different strategies. Market strategies. It is a marketing concept, 4 P's principle, right? First, product, price, promotion, and place. You have to put your product in a plan for a right product and put the right price and promote in a innovative way, as well as you have to put that product in a right place to sell your product. Digital marketing. Maximum nowadays, digital marketing playing a major role. Any company, if you see, if we are booking for any reservation ticket, IRCTC ticket, or any website, if we are opening digital marketing, and right side as well as left side and right side, they will show display lot of marketing products, right? There are so many tricks are there. Social media marketing, search engine optimization, pay per click, advertising. Means for every click they will provide some money, as well as they will also promote their product. That is pay per click. Now it is recent trend, pay per click. Sales strategy means how you will adopt your sales channels, how you will product sales forecasting and projections, and sales team structure and training, financial projections, break-even analysis. Every company at initially they will not reach the break-even. They will at the investment level. After certain stage, they will reach the break-even analysis. After reaching the break-even analysis, they should be very cautious. Yes, sir. We have to think how to travel towards the profit line, right? So many products, if you take Reynolds pen, right? Its product once upon a time, it is very high range. It's a sales. Everyone used Reynolds as well as Reynolds pens, right? Nowadays, due to other west side as well as pantaloons, so many are offering with the same and low cost. So people are diverting towards that side, right? Raymond's is one of the brand, but now still they are existing in the market. They are not remodifying the structure. Next, cash flow projections, operations and management, human resources and training, sustainability impact. So here, sustainability development means here people, planet, and profit. People in the sense our human beings, planet in the sense environment. Our product must be environmental free. Means it should not pollute the environment. New next era energy. I said this video. We will later on. We will think if time permits. We will think. India is a land of opportunities for sustainable sectors such as renewable energy, waste management, organic farming. Nowadays, everywhere organic farming. People are taking 100 acres, 500 acres, 200 acres. Big people means industry people. They are doing the organic farming. If same product, if you purchase without organic farming, it will available with low cost. Even though we will think for the organic farming products, right? Why? Because it is good for health and environmental free pollution. Green construction, electric mobility, as well as social enterprises, and sustainability leads your entrepreneurial success, long-term brand reputation, customer trust and loyalty, investor confidence, risk reduction, and competitive advantage. Risk analysis is also there. In the supply chain management, there is a lot of risk. The product is supposed to reach on so and so date. If you are delaying it, means you are losing your sales. Means automatically customers will travel towards the another product. They move to other products. Greenwashing ecostations, growth strategy, expand product line, enter new markets. So small scale industries in this Vidhan Sabha line only I have taken to my students also. Why? Because they should know live experience what is small scale industry, how they are running it. right? In small scale industries, government is also saying you should not stick to one particular product only. You have to expand your product. You should expand your product. Clear? Invest in R&D, research and development. Example, IKEA sustainability expansion initiatives, potential inputs for success. So competitor analysis, these are all at beginning we have discussed. So this is my conclusion. Together, a business plan, marketing strategies help entrepreneurs and businesses. Thank you.
Our audience question.
Any questions?
Sir.
Thank you. Okay, once again, it's a great honor and pleasure to me to invite this international conference INCON 2026. So thank you for your gracious support. Thank you.
Thank you for sharing your valuable insight with us. Your knowledge truly inspired us and enlightened everyone present over here. And now I would like to invite Dr. Sachin Darsal, Head of the Department Microbiology and Biotechnology, to felicitate our speaker, Dr. GVV Jagannath Rao sir, with memento kit and certificate. Can we have a big round of applause? Moving forward now, I would like to invite Dr. Mamta Patra ma'am, Associate Professor Biotechnology, to welcome our speaker, Dr. Pallavi Sana ma'am, with a bouquet as a token of gratitude. Now, Virita will take over for the introduction part. Thank you so much, everyone. Joining us next is Dr. Pallavi Sinha ma'am, who is currently serving as an assistant professor in the Department of Zoology at Government MPG College of Science, Raipur. Currently, 2 students are pursuing PhD under her supervision. Her special achievements include DBT Research Associateship in 2013, Senior Research Fellowship CSIR in December 2009, and she cleared CSIR net multiple times. Her research focused on biohydrogen production from various feedstocks and processes, including dark fermentation and photofermentation. She has authored numerous research papers in high-impact journals such as the International Journal of Hydrogen Energy. She has contributed a book chapter and an article entitled IIT Kharagpur Leads the Way for Biofuels published in magazine Akshay Urja. So I request Dr. Pallavi Sinha ma'am on stage to share her valuable thoughts with us.
Hello, good morning, everyone.
Welcome,
first-
ma'am. Before you start,
Yes,
so
sir.
we have time limit of 15 minutes.
Okay, sir. Okay, sir. Thank you, sir. So, starting with my presentation, it is a smart integration of biohydrogen production and bio-waste valorization for sustainable development goal implementation. In the year 2000 and 2015, the United Nations has proposed the Sustainable Development Goals. It is a set of 17 goals that was described by the United Nations. Among these goals, Goal 7, Goal 12, and 13. These goals are for the climate, environmental protection. And these goals basically, the main requirement of these goal is due to the over-exploitation of the fossil fuel. The over-exploitation of the fossil fuel created the problems like the health issues, there are increased asthma attack, and in case of children, there's also neuro developmental damage is also seen in case of children's. And due to the mining of coal, habitat is also disrupted. These are the some ill effect using the fossil fuel. Now, what is the alternative? Alternative is the renewable energy sources. If we see, if we have a look on the global energy transition, then we can see that from 1970 to 2010, there was a dominance of the fossil fuel. We globally all of us has relied on the fossil fuel, and the over exploitation of the fossil fuel created a problem like air pollution, health hazard, etc. By the year 2015, when the UN proposed the Sustainable Development Goals, along with there was also a Paris Agreement, which advocates to global net zero target by the year 2030, 2050, while India aims it at 2070. To fulfill this target, we are globally the energy. There is a transition of the energy sources from fossil fuel towards the renewable energy sources. And among renewable energy sources, we can go for the nuclear energy, tidal energy, hydro energy, geothermal, wind energy, solar energy, and the bioenergy. Bioenergy is, we can harness the bioenergy from the biofuels. And biofuels may be solid biomass, it may be liquid biofuel, it may be gaseous biofuel. My work is targeted on the gaseous biofuel, especially hydrogen. Then what is the need of hydrogen? Why we can use hydrogen as an alternate source of energy? First of all, it is zero carbon fuel. It has the highest energy content of 142 kilojoule per gram. It can be used directly in a fuel cell. And the most important is that on combustion, hydrogen produces only water. This is a union cabinet. India also advocates the use of hydrogen, and various hydrogen producing project has been launched. These are the sites where these are the sites in India where the green hydrogen is making. Now, the second thing is that with the population growth, with the increase in population, two main issues arise. First one is the bio-waste accumulation, and second is the present source of energy is not enough to fulfill the present population. So what we can do, we can convert the bio-waste into the bioenergy, that is the biohydrogen. So this concept is called as bio-waste to bioenergy, where we are targeting the bio-waste to convert it into the biohydrogen production. Globally, hydrogen is produced by the electrolysis, steam reforming, biomass gasification, coal gasification, and the biological methods. These methods, that is electrolysis, steam reforming, biomass gasification, and coal gasification, these have the negative effect on the environment, and these are the energy intensive process. While if we go for the biological method of hydrogen production, then this method is not energy intensive, it is non-expensive, and most important, it can use the bio-waste. We can use waste as a substrate to produce hydrogen. These are the biohydrogen production process. Hydrogen can be produced by light-dependent process and light-independent process. Dark fermentation is a light-independent process. And the most important thing is that ये क्लिक नहीं हो रहा है क्या? ठीक है, हो गया है. The advantage of using dark fermentative hydrogen production is that it is light independent process, so there is no need of energy input. The higher rate and yield of hydrogen production and various organic waste can be used for the hydrogen production process. Dark fermentative hydrogen producers. The dark fermentation can be carried out by the microbes, And these microbes can be either they are facultative anaerobes or obligate anaerobes. So these microbes are basically, we can say these are the bioreactor, we can compare it as a bioreactor which can convert the biomass to the bioenergy. These are the some microbial community which are exploited for the hydrogen production. The metabolic pathway of hydrogen production is basically a glycolysis, which can be done in each and every cell of all the living organism. Here, glucose is first converted into the pyruvate. Later on, this pyruvate is converted into the formate by the enzyme system called as pyruvate formatase, and formate is break down to produce the hydrogen. While one more system is there, which is mediated by the PFOR, pyruvate ferredoxin oxidoreductase system, and NADH ferredoxin oxidoreductase system. The NADH produced in the living cell by the various process should be oxidized to sustain the life of the cells. So these NADH is oxidized by transferring its electron to the ferredoxin by means of NFOR, and the electron released to ferredoxin is converted to the hydrogen by means of hydrogenase enzyme. The beauty of this metabolism is that various other products is also accumulated during the dark fermentation, which are lactate, ethanol, acetate, butyrate, and butanol. If we talk about the microbial growth system, then the growth medium of fermentative bacteria should contain carbon source, nitrogen source, minerals, and vitamins. The nitrogen source, here we are targeting biowaste as a substrate for the biohydrogen production. For nitrogen requirement, we can use de-oiled groundnut cake, mustard de-oiled cake, water hyken, etc. And carbon requirement of the microbe can be fulfilled by using the agricultural waste, industrial waste, and the municipal waste. This is a case study very well known. In every year during the month of September to November, basically in the region of NCR, parali burning is there, and parali burning creates the air pollution. What we can do, we can use the parali for the production of either bioenergy or biohydrogen. If we talk about the Chhattisgarh, then Chhattisgarh is a very good site for the biohydrogen production, because we know that Chhattisgarh is known as the bowl of rice in the India due to the high production rate of rice. And Chhattisgarh is also surrounded by the MP and Maharashtra. MP is known for the high production of soybeans, while Maharashtra known for the high production of groundnut. So these raw materials, the waste byproduct of groundnut industry, soybean industry, and rice industry, can be used for the biohydrogen production. But the main problem is using the bio-waste is that agricultural bio-waste is made up of lignocellulose, and microbe cannot assess these lignocellulose as such. So we have to go for the pretreatment process. The pretreatment can be done by the acid, microwave, steam, and other process. After pretreatment, the lignocellulosic form of the agricultural waste is converted into the form which can be assessed by the microbe to produce hydrogen. These are the steps for the pretreatment process. These are the comparison of the various pretreatment process and the hydrogen evolution or hydrogen production. The beauty of dark fermentation is that we can, on one hand, we can produce hydrogen by using the bio-waste, either agriculture or industrial bio-waste, and the spent media that obtained after the process of fermentation is still a rich source for various other substances. For example, we can extract ethanol, butyric acid, propanediol, and other substances from the spent media. Or we can use the spent media as a raw material for the production of biomethane, biobutanol, lipid, electricity generation, even hydrogen production by photofermentation or by algae. These are the examples where ethanol is used by the spent media of dark fermentation, butyric acid recovery, and here methane can be also formed by the spent media of the dark fermentation after hydrogen production. Okay, I'm concluding. What we can say that by these two-step process, we can enhance the energy recovery. So coming to the conclusion, the spent media can be used for the extraction of substances and also for the process of the methanogenesis, MFC, MEC, etc. And then again, concluding my presentation, by the process of biohydrogen production through that fermentation, we can fulfill the sustainable development goals as proposed by the UN in 2015, specifically SDG 7, SDG 12, and SDG 9 and 13. And on last, I will conclude that treat the earth well. It was not given to you by your parents. It was loaned to you by your children. We do not inherit the earth from our ancestors. We borrow it from our children. Thanks a lot.
Any question from audience? Question? Thank you, Dr.
Thanks a lot, all the organizing committee and members of this conference.
Thank you so much for sharing your knowledge with us, ma'am. Now, I would like to invite Dr. Depi Chandrakar, Assistant Professor, Biochemistry, to felicitate our speaker, Dr. Pallavi Sandha, ma'am, with a kit, bouquet, kit, certificate, and a memento. Our next speaker, Dr. Nagendra Kumar Chandravanshi, sir, joining us with online. Please welcome them with a big round of applause. Now, I hand over the mic to Ayushi for the further introduction part. Thank you. Now, I introduce our next speaker, Dr. Nagendra Kumar Chandravanshi, sir, who is currently working as an associate professor at the School of Studies of Biotechnology, Pandit Ravi Shankar University, Raipur. With a research and academic career spanning over 15 years, his expertise lies in the fields of mushroom biotechnology, functional foods, drug discovery. His research efforts have yielded substantial outcomes, resulting in the publication of over 30 research articles in reputable journals, along with paper presentations in over 34 national and international conferences and contributions to 32 book chapters. He also holds 3 patents to this name. Engaging actively within the scientific community, Dr. Nagendra Kumar Chandravanshi, sir, is a lifetime member of prominent organizations. Come. I'm sorry for the change. I hand over the mic to Edith. Let me continue his introduction. His contributions have been recognized through notable awards. The Indian Aerobiological Society awarded him the Best Technical Presentation Award in 2026, and the World Researchers Association's Society bestowed the honor upon him as a fellow member since 2023. Now I invite Dr. Nagendra Kumar Chandravanshi sir to online. Due to some technical issues, we are moving forward. Now I'd like to invite Dr. Sachin Das sir, head of the department Microbiology and Biotechnology, to welcome our esteemed guest, Dr. Santosh Kumar sir, with a bouquet. Now Vedita will take over for the introduction. Without delaying, I would like to introduce Dr. Santosh Kumar sir, who is currently working as an assistant professor at Kalinga Institute of Industrial Technology, Bhubaneswar. Prior to this role, he worked as Ramalinga Swamy Fellow 2021 to 23 at Department of Biological Science, BITS Pilani, Goa campus. Dr. Kumar's research efforts have yielded substantial outcomes, resulting in the publication of 14 research articles in reputable journals like Science Advance, Neophytologist, etc., along with oral presentation in several national and international conferences. His contributions have been recognized through notable research grants like Ramalinga Swamy MP Fellowship by Department of Biotechnology and DST Core Research Grant by Department of Science and Technology. So I request Dr. Santosh Kumar sir to come on stage to share his presentation with us.
Am I audible? Okay, good. Thank you. Okay, sir. So I will try to finish in 15 minutes. I think I will finish in 15 minutes. So I would like to thank the organizer for inviting me and your student for a very nice introduction. So my topic is silicon in sustainable agriculture and the silica deposition mechanism in grass silica cells. So the bright cells that you see here, this is a grass leaf, basically sorghum leaf, and the structure that you see here, they are silica cells, the dumbbell-shaped structures. So she already introduced me, but in short, I will just explain about my introduction. So I did BSc Agriculture from Assam Agricultural University, Masters from Pantnagar, Uttarakhand, then PhD from Pune. Then I worked for 1 year at Bose Institute, Kolkata, then 4 years Hebrew University of Jerusalem as a postdoc fellow, and then 2 years, almost 2 years in Weizmann Institute of Science, Israel. And then I worked as facility in charge of electron microscopy facility at NCBS Bangalore, which is one of the the best biological science institute in India. And then I joined Ramalinga Swami Fellow at BITS Pilani, Goa campus. And then since the last 3 years, I'm working as assistant professor in KIT, Team to the University. So this is our campus, which is a very beautiful campus. I mean, your campus is also very nice, very beautiful, and I invite the faculty members here to come and visit our School of Biotechnology in KIT University. So our School of Biotechnology has many facilities. For example, we have HPLC, SIM, scanning electron microscope, confocal, computational lab, upstream processing lab, PCR, and different high-end instruments. Since I'm also a part of the core research facility, the CRF, so also we have, for example, in CRF, many high-end instruments, for example, liquid chromatography, LCMS, atomic force microscope, and we have scanning electron microscope, high-resolution scanning electron microscope, and several others. So now I will proceed towards my my topic. So silicon is a highly beneficial element. Basically, it can provide defense against any sort of pathogen attack or any sort of biotic or abiotic stress. So silicon is really important for sustainable agriculture in India and everywhere. So how plants, they uptake silicon? So because the soil, you can see, is made of 28% silicon, so plants obviously uptake silicon from soil as silicic acid, which you can see, this is the structure of silicic acid molecule. So when the concentration of silicic acid molecules increases, then two silicic molecules, when they come close, they lose H2O, and then they form silicon oxygen silicon bond, and that's how they deposit solid silica. So silica is deposited at many places in plants, but we have, I am working on only one particular cell, which is called silica cell. These silica cells are present on leaf. So you can see these are the leaf veins of sorghum, or in case of any grass. And the cells that you see here in scanning electron microscope, so they appear bright if they are filled with silica. And those cells are dumbbell shaped. Sometimes they have 2 to 3 lobes, or sometimes maybe even 4 lobes. So in order to see how silica is deposited, what we did was we followed the deposition of silica, like how silica is deposited. So here you can see this is a very young leaf in which silica is deposited. So other than this young leaf, silica is not deposited in silica cells. So this is the youngest part of the leaf, and then as you go up, the cells, they get older. Okay, so cells at the top, they are older, and at the bottom they are young. So I used a dye which stains the cytoplasm green if the cell is viable. So cytoplasm, you can see, will be green, in green color, and the vacuole, because in plants the vacuoles are quite large, so the vacuoles will be black in color because the vacuoles are not stained. So here you can see when the cells are quite young, so we rather cannot differentiate between different kinds of cells, and the vacuoles are quite large here. And then as we go up, it means as the cells mature, you can see the cells, you can look at the arrows. So the arrows point towards the cells, which are silica cells, which are kind of developing, still developing, but you can see the vacuoles are quite large here. The vacuoles are shown here with star mark. So these cells, which are marked with arrow and vacuoles, like they are black in color, and you can see the cytoplasm, viable cytoplasm, green in color. When the cells further mature, then you can see, you can look at the arrows. So then you can see the cytoplasm, the vacuoles, they have reduced in volume. And then further, if you go, then you see the vacuoles are further, they get smaller. And sometimes you see, for example, these two cells you see with arrowhead, the cytoplasm is now very constricted. It has, it's not touching the cell wall, rather, it has constricted. And now you can see the cells here, they are dead because they are not showing any green cytoplasm. So this is how the cells, they develop. So because we saw that the vacuoles, they get smaller when the cells mature, so we wanted to see if silica deposition results as a process of vacuoles getting smaller. So if the vacuoles, they have a role to play in silica deposition. So what we did, we looked at the cells at a particular stage when the vacuoles are quite small. They have grown small enough, and then we subjected the same leaf piece in scanning electron microscope. So this is confocal light microscope, this is electron microscope. Now I told you that if the cells are filled with silica, they will appear brighter. But here the cells, they do not appear brighter. It means the vacuoles, even if they get smaller here, we don't see silica deposition in these cells. So this rules out the role of vacuole in silica deposition. And because we had seen few cells with very smaller cytoplasm, like these cells, you can see the cytoplasm is not touching the cell boundary, but rather it has constricted to a very small volume. This was very intriguing because, this was obviously not expected because the cell membrane must touch the cell wall. So this was not happening. So we wanted to see if these like reduced cell cytoplasm, the reduced cell volume or the cytoplasmic volume, if it has anything to do with silica deposition. So again, we went for correlative microscopy, and then you can see, so these cells which are shown with bulb here, so you can see the cytoplasm is constricted. They are small in size. And then when we looked at the same cells, so here you can see in, these three cells with bulb, they are shown here in like magnified view here. You can see the magnified view. When I looked at these same cells in scanning electron microscope, you can see they are bright. So it means the cells, they have smaller cytoplasm, they have silica deposited. Okay. So we came to a conclusion that, okay, this may be the mechanism of silica deposition. So this is a cell. This cell produces some sort of biological factor, which we hypothesize that this could be a protein. So these cells, they are filled with this protein. They are maybe packed in vesicles. And at the time the cell is ready for silica deposition, the vesicles, they fuse to the cell membrane, they secrete the protein out, and then inside the apoplast, we call it. So once the protein comes in contact with the apoplastic water, immediately silica gets precipitated, and silica precipitates in between the cell membrane and the cell wall. And this is how, because the cell is continuously secreting the protein, so continuous silica deposition is taking place, and after some time, the cytoplasm, it gets reduced to a very small volume, and ultimately the cell dies. So this is what we proposed. So I will not go into the detail of the protein, but we also found the protein that is responsible for silica deposition in these cells. This was also published. So we found that protein. So this finishes what I did in Hebrew University of Jerusalem. Then I move on to, there's just one slide, which is from my another postdoc study in the Weizmann Institute of Science. Can you guess what could be it? This is a scanning electron microscope image. And this is ice. Okay. So this is ice which has been polished. Now this is seawater, frozen seawater. In the frozen seawater, when I will press this switch, you will see that a cell will appear from inside. So basically it is like, what I did was three-dimensional imaging of a particular cell in its native conformation. So the sample was frozen in such a way, the process was so fast that even the water molecules did not get time to crystallize. It was vitrified. The process was so fast. So when we vitrified it, basically, I will explain in very short how we do it. So it's like turning over the page. So we first image it, then we remove 10 nanometer, again image it, 10 nanometer, we remove, image it. So this way, we keep on imaging, like hundreds of images we get, and then finally, from those hundreds of images, we can create three-dimensional structure of anything that we, anything that we are, we want to create three-dimensional structure. So you can see. So this is how this, from top cell to the bottom, that we see chloroplast, nucleus, vacuoles, white color nucleus, green color chloroplast, blue color is your vacuole, orange color is mitochondria, so pink color is mitochondria. This is how the cell looks. So just in one slide, I try to explain it. So now let's move on to my current research, which is going on in my lab. So, I have two projects right now in my lab. So one is related to the correlation between lignification and silicification in sorghum silica cells. So lignification, lignin is deposited in the cell wall. Okay, and silica is also deposited in between the cell wall and the cell membrane. So we wanted to see if there is any sort of correlation between silica deposition in these cells and lignification, because few authors, they proposed that lignin deposition or lignification might play some role in silica deposition in these cells. Okay, so here you can see this is silica cell, this is a cell wall, and the lumen is the cell lumen, the cytoplasm is getting constricted, this is the cell wall, and now silica is deposited here. So we wanted to elucidate the role of lignin here in case of silica deposition in these cells. So for that, what we did, obviously, we took one wild type, and then we took two lignin mutants, which are BMR6 and BMR12. So these two are lignin mutants. So it means the lignin deposition in these two plants is, the lignin here is mutated, or the content is very low, and also the its composition, that's also different. Okay, so what we did was, again, we went to a scanning electron microscope. So this is wild type, this is BMR6, and this is BMR12. So you can see, when we looked at them in scanning electron microscope, and there is something called EDX, or energy dispersive X-ray spectroscopy, through which we can identify elements. So this pink color that you see here is wherever silicon is present. The machine gave it pink color. So you can see these are the silica cells, and these silica cells, they have already deposited silica. Okay, even in the mutants, there is silica deposition. So at least it appears that silica deposition in lignin mutant, it does take place. But we could take only a few images, right? Because it's not possible to go through thousands, or even, because in a leaf there are millions of silica cells. So we wanted to quantify it, and quantification was obviously not possible in scanning electron microscope, because that's very time taking. So what we did was we quantified it using a process which is called spodogram preparation. I'm not going into the details of it. But what we found was the number of silicified silica cells Okay. Okay, so we wanted to compare the number of silicified silica cells in percentage, okay, because there are millions of cells. So when we compared the level of silica deposition in wild type as well as two mutants, there was no significant difference. It means the lignin mutation does not affect the number of silica cells which get silicified. So then we wanted to see, okay, it doesn't affect the number, but does it affect the cell's physiology, like the timing of silica deposition? So for that, what we did was, again, we looked at the average number of silica cells, which are silicified in tandem. And then what we did was, we again took the leaf, from the young part to the old part, so that it will give us some idea whether there is any difference in the whether there is any difference in the pattern of silica deposition in these plants. Here you can see the wild type, which is in black. So this is the pattern we get. But in case of the lignin mutants, red and blue, so the silica deposition starts earlier than silica deposition in wild type. So in case of, for example, here, this is the middle of the leaf. So the silica deposition in wild type starts somewhere in the middle of the leaf. But in the case of lignin mutants, the silica deposition starts a bit early. Okay. So, and then we said, okay, silica deposition starts early, but then we try to compare the total silica content in mature leaves of these three genotypes. And this time we found that in the wild type, total silica content is significantly less than BMR6, one lignin mutant, and much more significantly less in case of BMR12, another lignin mutant. Even between the two lignin mutants, there is difference in silica content. So we came to the conclusion that, okay, alteration in lignin does not affect silica deposition. At least it doesn't inhibit silica deposition, but rather it enhances the silica deposition process. So because both lignin and silica, they make the cell wall stronger. So the cell, if it is devoid of lignin, or if the lignin content is less, sorry, not devoid, lignin content is less, then the cell senses it and then tries to reinforce the cell wall using silica. So there is some sort of compensatory structural adaptation in case of lignin mutants, that when we reduce the lignin content, then silica deposition, it enhances. Now the other project, so it is about the ultrastructural changes in rice silica cells. Previously I was talking about sorghum, now this is rice. So here you can see, okay, so in between rice and sorghum, there is a difference. In sorghum, the silica cells are dumbbell shaped, and in this orientation, rice, they are dumbbell shaped in like vertical orientation. Okay, so this is okay. If you remember, whenever silica is deposited, it constricts the cytoplasm. Okay, so the cytoplasmic space gets reduced and reduced and reduced. So if the cytoplasmic space gets reduced, it means it will definitely affect the organelles present inside the cell, whether it's nucleus, mitochondria, endoplasmic reticulum, or any other organelle. So there will be some effect on the organelles present in the cytoplasm when the cytoplasmic space gets reduced. So for that, we force tracked the mitochondria using a dye which is called JC1. So with this dye, the viable mitochondria will stain red in color, but if the cell is dying or the mitochondria is dying, then the color will change to green. So from red to the green. So this is the control one. So here we do not see any red stain or green stain. This is only blue. The blue color is autofluorescence to look at the cell wall. Okay, so it will help us to identify the cell. So here you can see when the cells are quite young, we see the cells which are indicated by arrow again. So there are many mitochondria, not only in these cells, but also neighboring cells. Okay, so we see many mitochondria, but when the cells, they mature a bit, then we see that, okay, we still have some mitochondria here, but the number of mitochondria gets reduced here. And although, and in few cases, for example, in this and this, we see the cytoplasmic space, it has further constricted, and we see the mitochondria, few mitochondria in green and few in red, if you see here and here. So it's a mix of red and green. It means few mitochondria, they are viable, and few are in the process of dying. And it gives us clear idea about the cell volume, because the mitochondria now is now kind of being constricted in a smaller volume, here as well as here, and then the cells, they die. Okay. Then, okay, we saw, okay, mitochondria, then we should also look at the cytoskeleton. So the actin and tubulin, there are two main types of cytoskeleton. So actin is stained in green, tubulin in red. So here you see, this is again the control one. So we don't see actin here, because obviously this is control, but we see little bit of red here. This is some sort of autofluorescence. So we are trying to get rid of the autofluorescence, but still it gives us some idea about the cytoskeleton when the cells, they mature. So you can see here, when the cells, they are a bit much immature, then there are large vacuoles here. It corresponds to the vacuoles, obviously they will not be stained, so that you see here. Then we have red color, which corresponds to actin, and red color is tubulin and green color is actin. So you can see the red color is kind of everywhere it is there except the vacuoles. And then here you see the actin, it gets towards the cell boundary here. You see here, like here in this case. And the tubulin, if you look carefully here, so in few cells, when we looked at other cells, then we found that almost the entire cytoplasm is red. Okay, I think this will be better in the next image. Okay, no, first this image. So you see almost the entire cytoplasm here is red. So tubulin is present almost everywhere. And then we have here, you see the actin here. So the cells are dead, but we can see actin in different cells. Like sometimes we found a cell where this tubulin is very intense. I mean, the cell is very intensely stained with tubulin, which it means tubulin is present very strongly in these cells. And then when we try to track the ER tracker green, which tracks the endoplasmic reticulum. So in young cells, we see the vacuoles, and then the green color, we see the endoplasmic reticulum. When the cells, they mature, and the dead cells, then we see the endoplasmic reticulum is towards the corner. Okay. I would like to acknowledge Dr. Rivka Elbam. She was my postdoc advisor in Hebrew University. Dr. Asaf Gal, he was my postdoc advisor in Weizmann Institute of Science, and then Council for Higher Education Planning and Budgeting Committee, Israel, for offering me postdoctoral fellowship. This was a fellowship. Then Israel Science Foundation for funding the Sorghum project, European Research Council for funding the Diatom project. And I would also like to acknowledge Ramalinga Swami Re-Entry Fellowship to fund the Sorghum project, something like 1.15 crore, and ANRF or SCR, DST for funding me some 44 lakhs for Sorghum project. The two PhD scholars in my lab, Ankita and Jyotika. Achi Gupta, she's a former lab member. She has gone to another institute to join for PhD. And these are the research scholars, the research students who are currently working in my lab. Thank you very much.
Audience, question?
I have a question.
Yes, sir.
Thank you so much, sir, for such a wonderful talk. I would like to know because there's a huge problem of stubble burning.
Yes.
In the north.
Yes.
And एक तो उसका solution आता है that we can use it as a fuel. But one of the major constraints is the physical deposition in the
Exactly.
In the wheat and those. So like
Rice especially.
Rice. So what it could be, or what are your suggestions that how we proposals that we can solve?
Okay. Yeah.
What we can do?
See, silica deposition is very important for plants. So if we try to reduce silica content in order to make it, in order to reduce silica content, then what will happen? The yield will reduce by at least half. So if you reduce silica content, the yield will go down in such a way that it will not be economical for you, for the farmers. So this is why I will not advocate for reduction in silica content, but what I can advocate is that instead of burning the stubbles, maybe other techniques, for example, the stubbles, they can be collected, and then those stubbles, they can be decomposed, or we can let them decompose in the presence of some microbes which can dissolve silica, because silica can persist in the environment for very, very long time. Even the archaeological samples, so the other organic content is completely, they deteriorate or they get degraded. But the silica samples, we call them silica skeleton. So, for example, if you excavate soil, then maybe thousands of years back, there was some plants they were growing, and if the plants they deposited silica, so by looking at the soil, the pattern of silica deposition, we can say that okay, so 1,000 years back or these many thousand years back, this plant was growing at that particular time when there was some structural changes, and they got those plants, they got like embedded in soil. So this is why I mean, some alternate method, like other than stubble burning, we can go for decomposing them in the presence of some microbes which can really degrade silica. So that will offer a much better alternative compared to stubble burning.
You told that as the silica deposition plasma or constricted.
Yes.
So, is there any kind of increase in the turbulent pressure or something?
Okay. See, I didn't show that here because the time was really limited. So we have already shown that when the cytoplasmic the volume it decreases. Remember, in plants there are several plasmodesmata. Okay, so what happens? We checked with something called FRAP, or fluorescence recovery after photobleaching. So when we applied this technique on the cells which were depositing silica, we did not see any difference in between the cells which were fully turgid cytoplasm and the cells in which the cytoplasm was constricted. So this is why we came to the conclusion that silica is being deposited in between the cell wall and the cell membrane. So even when silica is being deposited, it does not in any way does not concentrate the cytoplasm. So my hypothesis is that maybe the cytoplasm, the cytoplasmic content, because of plasmodesmata, gets delivered to the neighboring cells. And this is why we mostly see that silica cells, in the major part of the leaf, silica cell exists with cork cell, silica cell, cork cell, silica cell, cork cell. So the two silica cells, they very rarely they are joined. So maybe.
Thank you so much, sir, for sharing your knowledge with us and letting the whole public present over here. And moving forward, now I would like to invite Dr. P. Shyam sir to felicitate our state speaker, Dr. Santosh Kumar sir, with the memento of
May I request Professor Sutlan sir, please do the honors.
Nagin sir, online? Online Nagin?
For the next, we have our next speaker, Dr. Nagendra Kumar Chandravanshi sir, joining us with online. For the introduction part, I want to hand over the mic to Ayush. Due to some technical issues, we are starting again with the introduction part of Dr. Nagendra Kumar Chandravanshi sir, who is currently working as an associate professor at the School of Studies of Biotechnology at Ravi Shankar Shukla University, Raipur. With a research and academic career spanning over 15 years, his expertise lies in the fields of mushroom biotechnology, functional foods, drug discovery. His research efforts have yielded substantial outcomes, resulting in the publication of over 30 research articles in reputable journals, along with paper presentation in over 32 national and international conference and contributions to 34 book chapters. He also holds 3 patents to his name. Engaging actively within the scientific community, Dr. Nagendra Kumar Chandravanshi is a lifetime member of prominent organizations. His contributions have been recognized through notable awards. The Indian Aerobiological Society awarded him the Best Technical Presentation Award in 2026, and the World Researchers Association's Society bestowed the honor upon him as a fellow member in 2023. Now I invite Dr. Nagendra Kumar Chandravanshi sir to present his valuable thoughts through online.
Hello. Hello.
Hello.
Hello.
Nagin sir, can you hear us?
Yeah, sir. Yeah, listen. Okay.
Okay, so we are connected, sir. You can go live. I'm handing over the mic to session chair, Dr. Gulabchand Arya, sir. He'll continue with it.
We welcome you, Dr. Nagin. You have 15 minutes for your talk and you can share your presentation.
Okay, sir. Sir, so PPT will share by some another person. Yeah, I have to say. Actually, sir, I have to put the phone. हाँ मैंने शेयर व्हाट्सएप किया हुआ है पीपीटी को शेयर किया हुआ है
Okay. You will share your PPT here.
ओके ओके
Hello. Yes, sir. You can start, sir.
Sir, please share the PPT. Actually, I couldn't see. So, share the PPT, sir.
We already shared your PPT.
Yeah, I'll just share.
नागिन सर दिख रहा है आपको पीपीटी?
Can you see the
Yes,
PPT, sir?
sir.
हाँ, शुरू कर लीजिए सर.
Good afternoon, all dignitaries present there on the dais, of the dais, and participants. First of all, I would like to extend thanks to Nagari committee members giving me chance. Actually, uh, I have to attend the session, but due to some emergency in my institution, there is some important program run by UC. I couldn't be here. So very sorry for that. So, but this opportunity presents in online. Okay, I'll try to my best. So please go ahead. Please go ahead. Please just slide. Please put the next slide, sir. Okay. So I am working on mushroom. And my today I'm going to talk about multimodal identification of the mushroom. Know that subsidiary is huge diversity in the forest nature, good condition, good climatic zone, and huge variety of mushroom available in the rainy season. Therefore, some of the mushrooms they have good potential to animal nature. Some they have very closest to this particular mushroom. They go very high closest to the some poisonous mushroom. So looking to this thing, we are working on some developing some concept, some tool to minimize this identification purpose. Especially most of the time we have seen in the pupil uptake, they are taken for some poisonous mushroom and they have some medical issues sometimes and lead to admission in the hospital, the family healthcare center, and sometimes multi-hospital center due to their toxicity level. So today I'm going to talk about multimodal identification of the poisonous mushroom, especially focus on diet. And I'm trying to talk about here morphology and their molecular analysis process. So please go to this slide. Please go to this slide. So already I've discussed what about the some challenges. So and typically basically I prepared for the oral presentation. Actually I because I'm so selection committee has recommended to me attend here. That's why I want to participate as a oral presenter. But as a key part presenter, I have limited content I will share here. So I will talk about as much as possible. So just look here below portion some important concept they are daily newspaper because most of the Muslim poison states not erased by the reported in report in terms of the media. So some cases reported in the local newspapers, some TV, media channels, sometimes different communities share profiles. So most of the cases not exposed in the public media, and so therefore is not concerned of the research items. So basically, I belong to the rural pupils, rural area. So I have seen number of really season. So that coming to these things, we have take the objective of the research article, research proposal, and started some research activity. So please go to the next slide. Please go to the next slide, sir. So now they're talking about we have collected some mushroom that to project the agricultural disorders. So firstly, we have to collect monophyllum species. They are very highly produced the agaricus. The pattern of same pattern like just like a mushroom agaricus. Just butter mushroom in the normally grown in the forest. They are group mushroom and they have same quality, same visible identity. So the people basically they have mistaken uptake and most of the time they choose wrong mushroom. So we have created the profile our study tools. The second thing, this is a poisonous mushroom. So we have to because it's poisonous mushroom, so no one talking about this mushroom because they're not part of the edibility nature, the high content protein nature. So now that time we are going to develop their mycelium consumption, spore characterization, and their we can try to understand their toxic. So they have some good important component for their biomedical aspect. So, like we go for the drug delivery and some antibacterial activity, then further the bioactivity compound characterization. So, this is our basic objective. And step by step, we have conducted this experimental procedure and looking to the some developmental of the product part, we have conducted. So, please go to the next slide. So, please go to the next slide. So this is a complete research methodology or objective that already stated in our objective parameters. The first select the mushroom in the different areas of the sector, like some prospection from the Namtari, some from Buster, some from the Rajnandgaon district, and some from the Raipur, our 2020 Center campus special forest region. And then we have conducted their microscopy, then biochemical, then water horizon, then ultimately what we have to find out their value content. So we go for the first initial screening by finger photography, then age, then FTIR, and then the biochemical activity like some DTS activity from the compounds and some antibacterial ACE activity. So please go to the next slide, sir. So this is the some data analysis portion. So as I said that this is a very poisonous mushroom. So we don't just compare with the edible and non-edible. So we are going to how to use this profile as a versatile uses like the discovery potential purpose. Came to reach about there. Uh, uh, some microbial biomass activity study, like some exopolysaccharide, good content, and some endopolysaccharide portion. So we perform the different. Firstly, we go for the RSL technology. RSL, that is some response surface system methodology. Then optimize the data, and accordingly we have created some suggested runs models, and they are basically uh, performed. So we have accordingly we have collected the data, and you just look the run number 22, they provided the highest number of the biomass activity. This is consumption biomass, and this is about the biomass targeted. So we have conducted. Similarly, we have conducted the EPH, algopolysaccharides. With algopolysaccharides, we would contain amount, and we have different runs there listed for the particular carbon sources, the particular temperature sources. So accordingly, we have developed this concept. So please go to the next slide. Please go to the next slide. Now come to the result and discussion section. So now just look here. This is the dried form of a propylum. This is the first figure talking about. The second one is the healthy. It's just if you anybody going to the forest for picking mushroom at rainy season, just assume they are just look like agaricus discourse. They are very highly edible and different mushrooms. So they are very too close to the agaricus discourse. So that is too challenging just verification. So first one, we have identified some then score study, some congruity study, some attribute study, and the technical simple notified photograph, and then go for their uh, images. So there is a difference between it and difference between profile molecular. But actually, looking to this particular talk, I am focused on the profile molecular, and and you just look this particular another DNA extraction or we have to run their data profiling, then following tree and try to understand their what is the genetic diversity in terms of what about the world level they are reported already. So please go to the next slide. So please go to the next slide. So with some findings, the finding basically what I'm just looking at the drug tools. The particular profile and content is a very heat stable. It's about 65 degrees Celsius. They are very heat resistant protein. And the flow phylum mushroom, they have a flow phylum bullifat. The bullifat is a good protein for highly stable temperature, heat resistant, acidic resistant. So it can be a part of the pharmaceutical application. So before going to digital development, we just go for the DPS assay and screening activity by different methodology, screening by the we have an and or we develop different products and then we run time. So we are selecting some we are so here only some specific run side. So please go to the slide, sir. Please go to the slide. So, one person I just this is the what actually the first one is going to the patenting and publication process. So I'm not mentioned here. Image analysis. We have developed a tool for the integration between profilum and the molecular and profilum and agaricus. We are using some general chemical method that particular in tribal people handed to the forest person can do in particular on-site activity, and then you can imagine what we have to take for animal purpose or not. So this study we have conducted. So this my study they are good, and we are going to the further implications like we have successfully identified morphologically and biochemically profile and agaricus species, and then successfully we have studied biotic compounds. They are good amount of the antimicrobial activity, a good amount of high antioxidant activity, a good amount of the biochemical. This conventional technology we have developed. This is paper-based methodology, just extract, just collecting some extract of the system and then put on the paper, and then add some like a beginner, like NaCl, like some salt sample in the household material, and then change the color. and this color variability that showing something different from profiler and agaricus. So this is the new key in our project. Similarly, we have going for further using some AI tools for the image sourcing tools and using some normal Android-based online and offline tools that is very easy to identification of the agaricus and profilable time. So this particular study can support to identifications of the mushroom between the in terms of the rural people, they prevent from the mushroom toxicity and they have option to select whether we have to go for the edible purpose or not edible purpose. So, so this is my this summary of the particular research. So thank you with this presentations. I hope audience will interact and if there are any queries, I will really happy to follow them. Thank you. Thank you for the giving me chance.
Thank you, Professor Nagendra, for insightful talk. Any questions from audience?
Sir, thank you. This is Vinit this side, sir. How are you?
Fine, Dr. Abhijit.
Thank you, sir, for such a wonderful talk and for insights regarding to the mushrooms. I'd like to know, sir, is there any cryptic species that you found during your endeavors of these mushrooms or any forays that are only present in our Chhattisgarh and not reported from other places around the world? And any special bioactive compounds that they have?
Yeah, profile bullet that also toxic and reported by some China, Japan, and some also Asian countries, and also including our India, Assam, and West Bengal. So this is the toxin there, but still in the Chhattisgarh people also intoxicant case there. So I nowadays I'm working with some doctor from AIMS. They have some forensic analysis expert. So they suggested this is the very good research tool because most of the person they have agaricus mushroom. They are very too similar agaricus. That's why they are highly toxic in the particular profile. So we will look for further study and may have good research output.
Thank you, Dr. Nagin. Thank you so much. So you may log out now.
Okay. Thank you. Thank you much for giving me the opportunity. It was thank you, sir.
Thank you, sir.
Thank you so much, sir. We sincerely thank you for taking your time to joining with us today and sharing your knowledge with us. And moving forward now, I would like to request Dr. Sri Ramesh, sir, Director IQAC, to welcome our next speaker, Dr. Kamlesh Kumar Shukla, sir, with a bouquet. Can we have a big round of applause for him? Thank you so much, sir. And now for the further introduction part, I would hand over the mic to Vidita. Now I introduce our next speaker, Dr. Kamlesh Kumar Shukla, sir, who is currently working as a professor at Pandit Ravi Shankar Shukla University, Raipur. Prior to this role, he worked as a research scientist at the Department of Biotechnology Institute, the Energy Research Institute, New Delhi, India. His research efforts have yielded substantial outcomes, resulting in the publication of over 41 research articles in reputable journals, along with paper presentation in over several national and international conferences and contribution to 8 book chapters. He has written 2 books that were published by international publishers like Springer and CRC Publications. Engaging actively within the scientific community, Dr. Shukla sir is lifetime member of a prominent organizations So I request Dr. Shukla sir to come on stage to share his valuable thoughts with us.
So, thank you for giving me an opportunity. I'm presenting here edible mushroom, a sustainable development ingredient for functional future food. Everyone wish to remain healthy and wealthy. So mushroom is the one key point which can help to. So without microbes, we cannot sustain in the world. We know the microbial role in single microbes play a significant role in human life. Everyone is to healthy. Primary source of health support come from food source. So the food source of mainly plants, animal, and microbes. History of food, as we know, the 19th century survival of food, 20th century convention of food, and 21st century functional food age. Chinese say medicine and food have the common origin, functional food. So global food system challenges, what are the challenges? Rapid population growth, as we know that. So currently the population is 8 billion population in the world. And coming the 2050, almost 10 billion population. So definitely key resources, natural resources are depleted and require much more food requirement and other natural resources. So global population expected the 10 million 2015, increased demand food and protein source, rising protein, climate change pressure, of course, resource limitations. है ना? Next, we have global food security. See the population growth almost and increasing food demand, climate change, and water scarcity. Right now, food demand this time is around per person 80 kg food are wasted, and almost 900 million people are facing malnutritious or uh, uh, next, yeah, climate change and water scarcity. Environment impact of current food system. Major environment pressure, livestock is emission, land and water uses, deforestation and food wastage. Here the 1.3 million tons edible food wasted annually worldwide. Food wastage generated 3.3 giga ton CO2. So these are the major challenges to food requirement. Land resources, as you know, कि half of habitat land use agriculture, 70% fresh water used by agriculture, 70%. And we know that 3% of fresh water available on the earth, and 70%, rest of 70% is tap water in glacier. Almost 1.3% are the fresh water, groundwater, surface water
we are providing. So again, the challenges of the water. So you can use hydroponics techniques, aeroponics techniques for sustainable manner. Environmental impact on current food system, livestock elimination, deforestation, water scarcity. Strategy address global food challenges, major approach to sustainable food system, transition toward plant-based alternative protein source, development resource efficient food production system, adoption climate smart agriculture, as you know. Adoption of reduction of food loss and waste, as earlier we said that the reduction of food loss. Today we are our actually culture, so we don't waste any food. Right now we are using in restaurant and other parties, so see the how much food are wasted. Ingredient functional food, nutrients dense food, promotion of circular bioeconomic model. Key objection: produce nutrition food and fewer resources and lower emission. Concept of future food. What are the future food? Food design, meet future nutrition and environmental demand. Right now, core characteristics is nutrient dense and health promoting, low environment footprint, efficient use of land, water, and energy. Scalable or large population compatible, sustainable and circular food system. Major category of food: plant-based, algae, insect, fermented, and mushroom. So the major food, future food category is the plant protein, algae, insect, fermented, and mushroom. So we're dealing with the mushroom. So they are without leaf, without buds, and without flower, yet they form fruit. Mushroom are the above ground footing body of fungi. They are the approximately 1.5 million people, species found in the world. Why focusing mushroom? Mushroom is the promising future food ingredient, nutrient dense food, rich protein, dietary fiber, vitamins, protein, minerals, etc. Low environment impact, efficient biomass, short production cycle. Nutrient sufficient, definitely protein, low fat, rich, as already discussed. Key bioactive compound in mushroom: major bioactive compound, polysaccharides, phenolic compound, terpenoids, and sterile anion. These property make a unique property of mushroom as a functional food. Ancient remedy, also the property of mushroom. Use the folk medicine since 16th century. Drunk as hot tea, chaga, small piece of place and kidney, and documentation. Anyway, modern scientific study already as a mushroom is the king of herbs, can say. So no side effect and nil toxicity, contain 100 of polynutrients. Ancient cancer research, diabetics, there are many medicinal property of mushrooms. So some facts: inhibiting melanin, inhibiting HIV, antibacterial agents, cancer. So nutrition value already I discussed with. There are several properties of mushroom: essential amino acid, non-essential vitamin, minerals, high dietary fiber. These are the nutritional data which can compare to or animal protein or plant protein or the microbial protein. So this nutritional properties make a good edible source. These are the data total 1,40,000 already described. 10,000 fleshy mushroom, 2,000 species probable edible, 80 species experimental, 40 species only 5 or 6 mushrooms are commercially cultivated. See the opportunity in this, how many mushrooms are reported in the world, and we are dealing with on 4 or 5 species. Some identification features: this cap, scale, gills. Without identification, you cannot find out the edible or poisonous. So these are the some microscopic feature: spore color, gills tube. This is the spore print technique, how to make a spore print. See the spore print. So is the major factor to identification of mushroom. These are the different pileus structure. This is a basidiocarp stalk, cap shape, convex, campanulate, bell shaped. There are different type of eccentric. Color, on the basis of color, you can also identify the some mushrooms. Other characters also. So next, microscopic feature, basidiospore and structure of gill trama. So these are divergent or parallel trama, which help to the identification of the other character taste, bitter, hot, mild. Smell also contribute the identification purpose. So they are the many characters which can help to identification. So sustainably advantage of mushroom, resource efficient food production, use of agriculture based substrate based cultivation, grow on lignocellulose base. As we know the key total in the Chhattisgarh around 800 million ton paddy straw produce. So how can use the improper and sustainable? Most of the paddy straws can burn, they create a pollution. Most of the deteriorate and cause a pathogenic fungi also. So these waste, wheat rice, corn bomb, sawdust, sugar cane bagasse, cotton, environmental. Low environmental footprint, green gases emission. Of course, this is the problem today is the greenhouse effect. So it's also reduce the greenhouse gases. Land use efficiently. So continuously the pressure deforestation and shrink the urbanization. So it's also use the land use. Water use efficiency. Next, role in food security. Current global market. So global market size, the global mushroom market value, the USD 70 billion. And in 2015, expected is to jo 120 or 160. So most of the key player of the China, 1965, China is producing only 5% mushroom in the world. Right now is producing 85% mushroom in the world. So, and there around 600 research laboratory there, and our India only one research laboratory in Solan. So how many gaps in there? Production trends globally, global production exceed 40 million ton annually. और इंडिया में जो है उससे भी कम प्रोडक्शन है, ऑलमोस्ट जो है 0.5 मतलब 50,000 ton kg mushroom, 50,000 kg. Asia country majority production, China as the leading producer. Regional market share, Asia Pacific dominating market 70 to 80% share. Rapid growth in China, India, Europe and North America. Technology opportunity mushroom based food, improve cultivation technology, substrate optimization, post harvest processing technology. They are the many challenges of this mushroom cultivation. Future prospective, expanding role of sustainable diets, plant-based food function and health promoting, sustainable protein source, functional ingredients. This last conclusion. Global food demand and serious sustainability and nutrition challenges. Further, food must be a nutrient-dense, environmentally sustainable, scalable mushroom of a high-quality protein. Next, my research. So, why mushroom? Again, they are the 17 or 20 points which can adopt this technology. Good taste and unique flavor, easy to cultivate and short crop duration. Time minutes, almost finished. Okay, just scroll down. So this is the cultivation practices, and I have started in during the terry open area. So cultivated this Plutus mushroom. These are the in our lab. These are the wild edible mushroom in Chhattisgarh. So this is the Rasula. These are the Flabosa bolitus. These are the Termitomyces, Volvirla. So there are almost 9 species in our Chhattisgarh which are unique property. This Amanita, Bondapuri, called as a local, use and treatment arthritis. Amanita subhemibafa, used for treatment arthritis. Caloside indica, stimulating. They are having a good source of medicinal property, which are not reported right now, just publishing the paper. So these mushroom demonstrate significant potential nutrients and ये Wolbachia highest protein, pulmonaris highest carbohydrate and significant fiber, Amanita cepiajana high phenol concentration, store antioxidant potential, Amanita subhemibafa superior antimicrobial activity, Wolbachia high flavonoid anthocyanin. These are the property which found in Chhattisgarh. We are first time reported earlier. These are not cultivated as you see. है ना medicinal mushrooms है Amanita muscaria highly poisonous mushroom. We are working on the poisonous mushroom right now. These are the Phylum, again the Marasmius, Phlebopus, stinghorn, Amanita, Boletus. These all are mushroom in Chhattisgarh. Thank you very much.
Thank you for the talk. From audience, any question?
If you wish to identification or mushroom technology, you're most welcome in our laboratory, Ravi Shankar Shukla University, Biotechnology Department.
There are lots of opportunities. I think your university also provide training for this.
Cultivation training. Right now, I'm not providing a training cultivation. I'm just identification and exploring the property and other research purpose. So we have two DBT projects. One is the 65 lakh and another is the 61 lakh. One our focus area Achanakmar. Next is the Bastar area.
Moving forward now, I would like to invite Dr. to welcome our next speaker, Dr. Dinesh Chilekar sir, with a bouquet. I'm really sorry for that, Mr. Parth. Now I'd like to invite, please see the sir, to felicitate our speaker, Dr. Kamlesh Kumar Shukla sir, with a memento kit and certificate. And for the introduction part, I'd like to hand over the mic to Ayush.
Now, I introduce Dr. Dinesh Kumar sir, who is currently working as a scientist C at CSIR Indian Institute of Chemical Technology, Hyderabad. Prior to this role, he worked as a senior research associate at the ClearSynth R&D lab at Secunderabad for a short time. He also served as an assistant professor at the Department of Chemistry at Romta College of Engineering and Technology, Finland. His expertise lies in the field of synthesis of isocyanate-free polyurethane for coating and adhesive application, hybrid material for optical application, and nanoparticles for anti-cancer activity. Publication of over 15 plus research articles in reputable journals, along with paper presentation in over 10 national and international conferences and contributions to 3 book chapters. He also holds 2 patents to his name. He has written 1 book that were published by international publishers like Springer Nature and ACS. Engaging actively within the scientific community, Dr. Dinesh is editorial board member of Springer Nature. So I request Dr. Dinesh Kumar sir to come on stage to share his valuable presentation with us.
Okay, fine. दो नहीं लगा दो ना यही लगा दो हेलो I'm audible. Good afternoon, everyone. So no need to introduce by myself actually. Okay, so I'm going to topic. So first of all, I would like to thanks organizing committee as well as Dr. Ramesh sir and Vineet sir to invite me as a keynote speaker here. Connected. So my research topic is sustainable non-isocyanate polyurethane material for high performance coating and adhesive application. So in order to explain the non-isocyanate polyurethane, first of all, I would like to explain what is polyurethane. So you might don't know what is polyurethane and why I'm working on this area and what is the potential in future or anything or industrial problem or any other things. So I will explain all these things. So the chemistry of polyurethane. Polyurethane is a versatile polymeric material which is useful. You know very well the matrices you are using, like you are sitting on the matrices. This is whatever the foam is there, that is made up of polyurethane. Okay, whatever the automobile seat you are working and polyurethane, that is made up of polyurethane. So what is the disadvantage of polyurethane? So polyurethane, if you are it is made up of 2 components. First one, first precursor is bifunctional isocyanate. You know very well what is the harmful of isocyanate. You know very well, this is highly toxic, highly hazardous, okay, highly inflammatory, highly insensitive, highly sensitive, and lot of disadvantage of the isocyanate. So if you are working that polyurethane, then you need to involve this isocyanate as a precursor. So isocyanate, in my case, whatever I am working, I need to avoid this isocyanate to make non-isocyanate polyurethane, or also known as isocyanate-free polyurethane. So if you are working like bifunctional isocyanate, that will be like reacted with polyol. Disconnected. In polyol, that is the advantage of this polyurethane reaction. That is completely polyaddition reaction. You won't get any byproduct here. So this is the advantage. But disadvantage is lot of disadvantages here. But still we are using that all polyurethane and all this thing. So you can see here, the polyurethane is a vast application is here: coating, biomedical, adhesive, elastomer, and foam. So whatever the application I have shown here, so in coating, adhesive, and foam, this is my main core area of my research. So you can see the polyurethane is a flexible polymer made by the combination of polyol and isocyanate, whatever this thing. The main problem of PU is, you can see the by looking the image and anything. If you are burning, because see, यदि आप end of the time क्या होगा? Whatever your foam you are using and whatever, that is going to waste. polyurethane and NiPu. You can see here, like health hazardous, highly toxic, and causing global warming. And what is the advantage of this NiPu? Eco-friendly, non-toxic, reprocessability, and this polyurethane also, see, this is non-biodegradable product. So you cannot degrade this one naturally or something. So it is like thermoplastic polyurethane. You cannot reform this one. And biocompatibility also. So what is the chemistry of non-isocyanate polyurethane? In order to synthesize the non-isocyanate polyurethane, we need again two components. One is cyclic carbonate, one is diamine. So yeah, epoxy, here we need epoxy also. This we can convert into the cyclic carbonate as is shown here in the slide using the carbon dioxide. If you are using carbon dioxide, definitely you are reducing the carbon dioxide from the atmosphere. So whatever the aim of our India, like carbon dioxide footprint, so that also we are reducing this one. So epoxy, that will be converted to cyclic carbonate, and cyclic carbonate again it will be reacted with diamine to form NiPu. NiPu is non-isocyanate polyurethane. Okay, this is the one research paper which I have published. So here also I have used the cyclic polycaprolactone based cyclic carbonate. Just I will explain this graphical abstract. If I am going to data, nobody will be interested actually. So here I have used the polycaprolactone base, now cyclic carbonate that is reacted with three type of different diamine: isosorbate diamine and commercially available hexamethylene diamine and linalool diamine, which is developed by me for the first time. So this is the polyurethane form, and this is the key significance of PCl. PCl means polycaprolactone. One pot synthesis, very easy to synthesize this one. And isocyanate free synthesis, biodegradability of polymer. We have shown biodegradability also. Amorphous polymer structure, definitely if it is polymer form, that will be amorphous only. No crystalline or any other things. Thermal stability and glass transition temperature is 45 degrees Celsius. So this is the synthetic route. So I'm skipping this now first. If you have any question, last you may ask. So this is the second hybrid non-isocyanate polyurethane by incorporating the cyclotriphosphogen is an inorganic material which improve the flame retardant behavior. As I told, the first of all the accidental whatever the things that is due to the bonding nature only. If I will make this polyurethane as a flame retardant, so there will be no side effect for this. So that's why this is the aim, and this patent also is published in January 9 actually. This is published, I have applied in 2025, then now only is published this patent. And this is the synthetic method of this polyurethane. And this is all, just I would like to tell why I use this one, that's all. The ATIR, FTIR, this is the tool which we can know the functional group of the polymeric material, where it is the urethane bond and what are the things. DSC means we are to identify the glass transition temperature of the polymeric material. And this is the NMR of this, whatever the organic component I have used, organic and inorganic. By using the PNMR, phosphorus NMR, carbon 13 NMR, and ESI mass, we can identify the structure of the polymeric material. And TGA means thermal mechanical property we can know from the polymeric material. And this is the flame retardant test. And this is another work we have used the vegetable oil as a to converting in the cyclic carbonate. So this I have used, and this is I have used for coating and adhesive coating application, which is my primary major area of the research. This is again FTIR, and here also I use to confirm this structure, same, and elemental analysis. And this is the TGA data. Again, TGA is, I can tell the thermal property we can know from that. And this is the biodegradability test. So I'm not explaining all this thing, otherwise you will be boring. This is the anti-corrosion test we have done. Here we have using the impedance workstation for the checking the impedance. And this is the antibacterial study. And this is the anti-angle study also we have done for this polymeric material. And this is ongoing project which are working right now. First is the iron oxide conjugated non-isocyanate polyurethane nanocomposite for high performance adhesive application. And another one is isocyanate free thermoplastic polyurethane. As I told, thermoplastic and thermo. setting. Both are different. Nobody is working on this thermoplastic polyurethane. Synthetic anti-cancer potential of carbazole loaded amine functionalized. This is my additional research work actually. And this is ongoing project is going on, this one. And this my PhD student who already this paper is under review now. So thank you.
Dr. Dinesh. Audience, any question? Thank you, sir, for knowledge. Continue.
Thank you so much, sir. Thank you so much, sir. You truly inspired and enlightened everyone present over here. Moving forward, I would like to invite Dr. Deepti Chandrakar, ma'am, Assistant Professor Biotechnology, to felicitate our speaker, Dr. Dinesh, sir, with a memento set and certificate. Thank you, sir. Now we have our next speaker, Dr. Rajiv Raj Chaudhary, sir, joining us with the online. Let's give them a big round of applause. And for the introduction part, I now hand over the mic to Ayushi. Thank you so much. Now I introduce Dr. Rajiv Roy Chaudhary, sir, who is currently working as a research associate scientist at ICRISAT, Hyderabad, India. Prior to this role, he worked as a visiting research scientist at the Agricultural Research Organization and University of Haifa, Israel. He also served as a teaching assistant for the MSc level course on plant pathology and diseases at the Institute of Evolution, University of Haifa, Israel. With a post-PhD research and academic career spanning over 8 years, his expertise lies in the fields of crop genetics, genomics, and breeding. Dr. Roy Chaudhary's sir's research efforts have yielded substantial outcomes, resulting in the publication of 60 research articles in reputable journals, along with paper presentation in over 15 national and international conferences and contributions to 11 book chapters. He has written 2 solo books and edited 3 volumes, all published by international publishers. His contributions have been recognized through notable awards. He recently received the Emerging Scientist Award by the AgriMeet Foundation in the international conference Harvest 2025. So I request Dr. Rajiv Roy Chaudhary sir to share his presentation with us through online.
Welcome, Dr. Rajiv. We cannot hear you, Dr. Rajiv. No, you are not audible. Not audible. No, sir, no. You are not audible now. We cannot hear you. No, no, we cannot hear you. No, sir, we cannot hear you. No, no. Raise the volume or something, do something there from there. No, still you are not audible. No,
Am I audible now?
yes, yes, you are audible now. Welcome, Dr. Rajiv. You can share your PPT, and we have 15 minutes for you.
Okay, just a minute. Can you see my slides here?
Yes, yes, we can see your slides. Please try
Okay.
moving if we will check if it is moving.
Now it's fine, right?
Yes, yes,
Okay.
you can start.
And I am very much thankful to the organizer for inviting me to present in this international conference. So as you can see from my title, this is based on the agrogenomics in action. So and I know this conference is not only for the science and technology based students and the faculties, it's also for the business and the humanities. So I am keeping my presentation is understandable for all of the journalists of the subject. Okay. So first of all, what we are now. So I am from the ICSAT. This full form is the International Crop Research Institute for the Strategic Tropics in Hyderabad, and this is one of the CGI centers throughout the world. You can see the many other CGI centers is spanning across the world, and also this EPSAT headquarters is in Hyderabad and also New Delhi. There is another office, and also in the Africa there are 8 centers of the EPSAT. And the EPSAT's main contribution is for the global food security. So our main vision is prosperous food security and also the resilient dryland agriculture. And our mission is to reduce the poverty, hunger, malnutrition, and we are working on the different challenging aspects due to the climate change, which is currently ongoing throughout the world. And we are also working on the basic 3 sustainable developmental goals, which is for the reducing the poverty and making zero hunger, and also the good health and the well-being for the consumers. So here in EPSAT, we are working on mainly 6 crops, and out of that, there are 3 legumes, major legumes: chickpea, pigeon and the groundnut. And other than that, also we are working on sorghum, palm millet, and also the finger millets. And recently, we have started to work on various small millets as well. So here, basically, we are mainly focusing on the Asia and the Africa. As you can see, as per the 2025 the Global Hunger Index, the majority of the India and the African continent is very serious issue for the hunger index. And also there is, if we are considering for the agriculture crops, there is a major reduction of the yield, which is around 20 to 50% loss by the 2050
by this year. So in the EPSAT, we are supplying various germplasm and the breeding resources throughout the more than 80 countries throughout the world, and it's spanning all those crops that I have stated before. And this is the global distribution of the EPSAT germplasm. You can see here, we have distributed throughout the world almost. So in agri-genomics, whatever we are doing, we are making the genomics revolution, and which is applicable for the agriculture, especially on our agricultural aspects, and to improve the crop performance, their productivity, and also the resilience to the biotic and the abiotic stresses, which is most important. And whatever the research we are doing in the lab, we are also trying to translate in the real field so that the farmers and the consumers will get the benefit directly from this. So for this, the translation of genomics work, we are using the various genetic resources, and as well as we are making the genomic resources to make the reference genome, genomes assembly, candidate genes, some of the diagnostic markers which is useful for the breeding pipelines. And through that, you can see the various genomic applications we are making, like the multi-access selection, some gene discovery, and also the duplication and some of the genetic diversity finding in the gene bank accessions as well. So here is showing mainly on the PGNP and the groundnut how we are deploying the genomic and the genotyping resource. So we have also some of the reference genome assemblies and also whole genome sequencing, resequencing, and the pan-genome sequencing for both of these crops. And regarding the markers, we are using 3 different types of the marker density assay: low density, mid density, and the high density. And we are making also the gene experiments as well. So in the PGNP, I am showing you the one of the most dominant trait, which is the determinate and the indeterminate type. You can see here through the picture. So in the determinate type, which is located in the middle of the photos in the diagram, so it's a very short stature and its flowering is very early. So if we are looking for the breeding improvement of the trait, so this is very much helpful for this trait to interface in the breeding pipelines for the PGNP. So here we have utilized also the haplotype-based breeding. Here you see how we are making the superior haplotype, because so one of the utilities is for making the haplotype-based breeding, also the genomic selection, and also the precise genome editing. We can use these tools. So also we are using the speed breeding tools in this aspect. And for the deterministic traits in the PGNP, we have analyzed all the whole genome resequencing data and the essential variations throughout the global 401 populations of the PGNP. Through the LD score, we have found at last the 3 different NPC haplotype: ACT, CA, and the CAT. So out of these haplotypes is present in 3 haplogroups, and which is spanning almost more than 380 populations. And also we have found some of the insertion and the deletions. So what is the basic role of this deletion? Actually, this 10-base pair deletion we have identified and validated among our populations that it is responsible for transferring the traits from indeterminate to the determinate type. So also in the PGNP, another important traits we have investigated, that is the sterility mosaic disease resistance. And for that we are using our 2 potent parents. One is the resistant parent and the susceptible parent, and we are making the process and making hybridization between them and producing some of the recombinant inbreed lines of the wheels. And based on those wheels, we are making the critical experiments, and through this detailed experiment on those balls, we have identified there is one gene responsible, and which is located at the chromosome number 4. And these genes actually we are deeply investigated inside, so we have found that there are some indels which is making the loss of function of those genes, and for that it becomes very resistant, and we are creating the sterility mosaic strains through that. And also we are using, because we have a lot of the wild accessions lines for both all those crops I have stated. So we are using also the pre-breeding, which is making the bridging between the gene banks and the crop breeding pipeline. So in some of the crops, which is like the broader genetic base, so we are using this pre-breeding and we are taking various genes and the important traits from the wild sources. But in our modern agriculture, we are preferring both the modern and the hybrid line. So we are taking those genes and our main intention is to replace those genes to integrate in the modern lines, and that modern line could be get some of the beneficial traits like some tolerant traits for the aromatic stresses, and also some disease-resistant traits you can see. And like here, I'm presenting here the more important and the thrust areas of the of some of the traits which is important for the crop wild related to we are taking. For the groundnut, we are taking here the stem rot and the late leaf spot resistance genes from the wild accessions. For the pigeon tree, there is the fall borer resistance and the brutage resistance lines. Also, the blight and the dry root rot and fusarium wilt is there. And in case of the sorghum, there is a perenniality and also the trigger resistance and the flow sensitivity. These traits we can bring from the wild accession to the modern lines. So here in this photo, you can see is the futuristic agriculture and which is supported by the digital agriculture as well. And here all of you know about the AI and the machine learning, which has a many like roles now embedded in the agriculture, not only in the medicine and the other allied subjects. And like this, in this way, we would like to see about the future agriculture for the crop development program. And this is directly related to the precision agriculture. And in the precision agriculture, in the digital farming, we can use different resource applications and then to evaluate them, and there are different options for the data sensing, and from that we can collect different agricultural data, and from data we can analyze those things and make the decisions, and through that actually there is the immense role of the artificial intelligence and also the machine learning. So here we can use this artificial intelligence in the agriculture, we can make some robotic systems which is helpful for the farming, and we can use different digital gadgets for precision farming and the precision agriculture. We can detect very early about the different pests and the diseases in the field after showing the crops, and also we can monitor the soil health, and also we can monitor the environment and also some of the climatic data and the onset of the future like abatic stress will come or not, and also we can use better resource use efficiency in the soil actually. So based on this AI and the machine learning, we have just started one pilot experiment in the PGMP. You can see here we are mainly using the autoencoder and the multi-layer perceptions, these tools. And while this is more important to predict the crop yield and also some allied phenotype, which is more important. And here we are comparing actually RL block, and we are using the AI model that how it can like some outperform the RL block, which is most confidently used in this way in the agriculture. So we are using here almost 8 locations, different locations, and we use more than 80 vision lines. And we have identified 1800 SNP across those 8 environments. And in this AI model, which is we can see is consistently and significantly outperformed in those all the environment, which is where the RR block is struggled till yet. So in this way we can accelerate the today's agriculture to make those the futuristic crops and the crop performance. Thank you, and I am heartily thankful for the DBT Department of Biotechnology for the funding, and also here our principal scientist, Dr. Manish Kumar Pandey from the USAID, and there are 2 bioinformaticians, Ms. Devika Talwar and Ms. Namita Dubey, which they are working very hard on those sequence analysis. And here is our genomics team, and I am also keeping my email ID for the further collaborations and inquiries further. Thank you.
Thank you, Dr. Rajiv, for sharing your experience. From audience, any question? Thank you, Dr. Rajiv. We do not have any questions. Thank you, Dr. Rajiv. So you may log out, and next time we will try to see you in person.
We sincerely thank you for taking the time to share your experience and knowledge with us. It has been a great learning opportunity for all of us. For the next, we have our next speaker, Dr. Prashant Singh, joining us online. Please welcome him. A big round of applause. I hand over the mic to Ayushi for the further introduction.
Dr. Prasad, I think you have two different devices, so we can hear other voice. Yes, now it's okay. No, wait. We still can hear some other sound from background. So can you fix it? Maybe I think you logged in two devices and both devices are nearby. Hello?
Hello.
Yes.
Am I audible?
Yes, you are audible. Just wait for 1 minute. We will introduce you and then we will ask you to share your presentation.
Am I audible, sir?
Yes, you are audible. Just wait for a minute.
Now I introduce Dr. Prashant Kumar Singh sir, who is currently working as an assistant professor at the Department of Biotechnology, Mizoram University. Prior to this role, he worked as a visiting scientist at the Department of Plant Science, the Institute of Agricultural Research Organization, Israel. He also served as a research professor at the Department of Plant Sciences, Henan University, China. With a research and academic career spanning over 12 years, his expertise lies in plant molecular biology with special reference to plant stress and development biology. Dr. Singh's research efforts have yielded substantial outcomes, including the publication of over 70 research articles in reputable journals, paper presentations at over 80 national and international conferences, and contributions to 50 book chapters. He has written 6 books published by international publishers. His contributions have been recognized through notable awards. He recently received the Best Researcher Award 2026 from Mizoram University. So now I invite Dr. Prashant Kumar Singh sir to share his valuable presentation with us through online.
Yes, Dr. Prasad, you can start.
Yes. Am I audible? I hope.
Yes, you are audible.
Thank you, sir, for confirming. And thank you very much ma'am, for giving me the information. And I also thankful to Dr. Nini for inviting me for this event. And partially I cannot make it physically because of my some engagement here. So today I will be presenting one of my projects that is reporting the role of universal stress protein in epigenetic seed dormancy and flowering transition in the area. So this universal stress protein has the name itself saying universal stress protein means stress is the what is stress firstly? Stress is any biological, physiological, any internal as well as
nervous signal, which can influence the normal happening physiological process inside the system. That is known as pressure, and the condition the plant or the animal who is suffering is known as stress plant or animal. So, as name itself saying, this universal stress protein. So, this protein is expressed under the different stress condition, various stresses that are known. So, these stresses are broadly classified in two types. One is the abiotic stress, another one is the biotic stress. So almost all these abiotic stresses like cold, heat, oxidative, drought, and osmotic stresses are there. And biotic stresses include the living beings such as viruses, bacteria, and nematodes, etc. So all these abiotic stresses largely they cause the accumulation of reactive oxygen species, and also they accumulate the phytohormones. So my basic test is under drought stress because this osmotic this drought stress is very frequent in Mizoram. Mizoram is a state which is a highland area, and here we have although heavy rainfall, but only in the rainy season. So here the farmers they cannot have this natural water body to irrigate the plants and agriculture. So for this, I wanted to develop a crop which can provide the drought stress tolerance so that we can have the Z farming system supporting crops. So for this, drought stress usually sensed by two different pathways. One is the ABA dependent pathway, another one is the ABA independent pathway. Here you can see like ABA dependent pathway, it is sensed by the NAV transcription factor and the trigger transcription factor, and then it activates the ERD1 and ERD, and which bind with the promoter region of RD29, which brings about the stress response. While the ABA dependent pathway involves the activation of signal receptor kinase 2, and they activate the series of transcription factors, and then they bind with the ABRE stand for ABA is used responsive elements. So it binds and then activate the drought stress responsive gene. So in response to drought, what happened? The stomatal closure will take place that will reduce the water loss and activate the stress responsive gene that involved with hospital protection, like protecting the biomolecules such as DNA, lipid, and aquatic, and some detoxification mechanisms such as the production of antioxidant enzymes and antioxidant and cellular repair system if there is any damage to the biological molecule, then repair system for the DNA, if there is damage, then it causes the DNA damage repair and cell division will be halted. So this is happening under the drought stress. And so now come back to the universal stress protein. As I have mentioned, that this universal stress protein expressed under the variety of structures. So now come to the molecular understanding of this protein. This USP protein basically has the two motifs. One is the ATP that binding motif, another is the ATP non-binding motif. So ATP binding motif is largely responsible for the energy status of the cells and then activate the stress response pathway. And ATP non-binding motif, it protects the factor molecules such as DNA, proteins, and numbers. While in the biotic stresses, this protein is also upregulated, although the mechanism under both abiotic as well as biotic stresses, how these proteins are protecting, these are just the bioinformatic analysis. So how they are protecting, it is still unclear. So we have started working on this protein when I was doing PhD 2010. I completed my PhD in 2014. So I was having this protein from cyanobacteria and LB, but this protein were never reported in the plants. So the model plant we have selected this Arabidopsis thaliana, so which is the model Sorte plant, which is it's very whole genome sequence is available and it has chromosome short life cycle. It's the best model system to study functional genomics. So when we look for this Arabidopsis thaliana, we find there are 44 USP proteins that are present, and it also expresses under antibiotic stress, and it has the conjure 140 to 160 amino acids, They form gamma to supply the protein, and they also serves as the chaperone based on the bioinformatics technology we came to know. And it also have the ATP binding moment that I have already discussed. So in order to confirm all these 44 USP protein that is named from 80 USP 1 to 41, we have performed the whole genome transcript analysis, and we found there are two USP 28 and 34. They express under the highest under the ABA stress. So this is a heat map which is showing this color range from 0 to 3. So if more darker means the expression is more. Then we did some bioinformatic analysis like this KT-SPA28 that are the dot express responsive based on this transcription study. So we performed this cytoscape analysis and we found that this KT-USP28 largely interacting with the KT-USP28 interacting with FAP1C transcription CD73 protein and VIP2 protein, while 34 interact with the CD73, VIP4, VIP2, and VIP6. And when we look for these proteins, they are interact with PF1CM. They are responsible for the flowering regulation. And 82OPS is bound with RCMM and VAL2, which is responsible for the epigenetic regulation of gene expression. So how this might be doing the job? So for this stress hormone and developmental signal, they activate FAP1. For this, we have already known mechanism before V5 sequence to de-escalation, and this activates the gene expression. While the parameter and the gene activation will take place, and then VAL2 it activates again the PRC2, and this activates the stone deacetylase enzyme, which again is the deacetylation of the stone protein, and DNA become naked for transcription. So transcriptional activation takes place, and flowering pressure genes like such as FLC and seed maturation genes become active. And this also activates the LFL gene, seed maturation gene, immune system, and flowering pressure gene. So then we perform this by using, since we get the large number of protein which are interacting with USP28 and 34. So the USP28 we generated we performed the H2 habit reaction assay, and then we have the vector which have the 28 as well as these protein like RCA1, B5, TDC73, 7 and all, and you can clearly see that they are interacting with each other. While an empty vector without USP28, they don't interact with the respective protein. So it suggests that the FAP1C components such as CDC43, VIP3, ELF3, VIP5, and also RCA1 VAL2 needs to have it assay. It suggests that 28 interact with these proteins. So they are involved in the this seedling development, flowering related gene, and epigenetic regulation of gene. Further, we confirm our finding with the high-speed biopsy assay. You can clearly see. So for further to confirm our findings, we generated the overexpression line, knockout line, respiratory line, and promoter reporter fusion line for expression pattern for loss of function study and functional analysis. Overexpression line for functional analysis, knockout for the loss of function study, and promoter reporter for expression line, and then we produce the translation reporter line to generate the rescue complementary lines. So these are the we have used the native promoter. So expression pattern, you can see this the gene is expressing in the young leaf, rosette leaf, 28 and 34 likewise. And differential expression of the media, and since this protein is expressed under the ADA protector, so we treated with the ABA 10 micromolar concentration, then you can see the expression is higher. And one important finding that we find that the 18 USP28 it expressed higher in the shoot region, while the 18 USP34 it expressed higher in the roots, not in the shoot. Then we perform the subcellular localization study. So 28 expression by using Nicosia leaf. So 28 is largely localized in the cytoplasm, and 34 is nuclear localization as well as cytoplasm. 34 is also present in the nucleus of the roots and instrumental guard cell. And then we observe the phenotype. So we find that the mutant of USP34 is having early flowering. You can clearly see the flowering is, and this is the white type background. Here the flowering is as normal, but in 34 mutant, the flowering is set early. So this could be a very important phenotype, like if a crop is suffering with the drought stress. So then if we are knocking out this gene, then the flowering will be early and maybe we'll be getting more productivity. So this is again the US28, the same phenotype, and also it has been we have found that this ABA on ABA treatment, the mutant shows sensitivity toward the ABA. So means ABA sensitive mutants are there. Then we also find the early germination phenotype like this 80 USP 28 and overexpression lines, they have the early germination. So germination phenotype, again the same study. So finally we can concluded that the abiotic RCN1 responsive transcription factor YF1 or YF2, they activate the USP. And how this USP regulate all these mechanisms, we are still under the process of understanding how they are regulating the flowering and seedling transition and response to the abscisic acid. Although we come to know that USP is regulated by these things, but these genes PAP1 and VAL2, but how this USP is downstream signaling, still we are in the process of doing this, understanding this process. So finally, I would like to acknowledge my collaborators and for this student, Pandurang Devde Ramarao. Now he is in France. So he is responsible for doing all this study, and this is Alex Burr. So he is working with him, and Dr. Santosh Satrai from ISA Mohali, Professor Rahul Kumar from University of Hyderabad, and Dr. Amit Mishra from Mizoram University. And I would also acknowledge the different funding agency like ANRF, UGC, ICMR, DBT, and CNRS, IPMP. One important information, we are organizing one research conclave that is dated on 25 to 26, and we had that abstract submission deadline is 15th of March. It is an international event, and I would be happy if one can register and come to the Northeast, which is especially the Mizoram Aizawl, which is known for the silent city, honking free city. With this, I would like to conclude my talk. Thank you very much. And this is a beautiful place in the Aizawl, also known as Moonland, and very clean AQI here. Now we have 20 only, respect to the other rest part of India. And I would be very happy if there are any questions. Thank you very much.
Thank you, Dr. Prasad. From audience, any question? Thank you, Dr. Prasad. We do not have any question for you. We'll proceed for next speaker. Dr. Prasad, you can log out. And we hope that in the next conference you will come personally and deliver your talk. Proceed for next.
Thank you so much, sir. Thank you for sharing your knowledge with us. And moving forward now, I would like to invite Dr. M.K. Ghosh, Professor, Department of Chemistry, to welcome our esteemed guest, Dr. Sushil Kumar Shahi, sir, with a bouquet.
Now, I usually will take over for the introduction. Now, I introduce a final invited speaker for this segment, Dr. Sushil Kumar Shani sir, who is currently serving as a professor in the Department of Botany at Guruvasinath Vishwavidyalaya, Glasgow. With an academic and research career spanning over 25 years, Professor Shani sir has developed strong expertise in nanotechnology, mycology, herbal technology, and medical. His research contributions are extensive and impactful, with more than 110 research papers published in reputed national and international journals, along with over 87 research papers presented at national and international conferences in 10 global chapters to his credit. He has successfully supervised 35 medical cases at 15 PhD projects, mentoring numerous research scholars who are now contributing significantly to academic research and industry. In addition to his academic and research achievements, Professor Shani sir has developed 18 eco-friendly and sustainable plant-based and herbal products for society and environmental benefits, contributing to prevention, entrepreneurship, and sustainable development. So now I invite Dr. Sushil Kumar Shani sir on stage to present his valuable thoughts with us.
Thank you very much. And thank you to the organizing secretary and organizer, all of the organizer, to invite me for this presentation here in this international conference. So I am presenting fungi-based approaches for green product development and long-term sustainability. You all know about Sustainable Development Goals. This, in January 2016, the 2030 goals of sustainable development are set by the United Nations. And is for achieving environmental, social, and economic growth through a green, better, and cleaner production technology. And sustainable development is a development process which optimizes natural and man-made resources to meet the need for everyone and create wealth without compromising the environment and future generation. Fungi are the heart of this sustainable development. And fungi play key roles in achieving the sustainable development through the United Nations goals. In SDG 2, zero hunger. Fungal phytoplankton, you know about that, enhance soil fertility and crop yield, while mycoproteins and edible mushrooms provide sustainable protein-rich food. And SDG 3 says good health and well-being. Fungi produce safe, life-saving antibiotics like penicillin, immunomodulators, and improve nutrients through food. And SDG 6 says clean water and sanitation. Microorganisms help further purify water by breaking down pollutants and harmful chemicals. And SDG 9 says industry, innovation, and infrastructure. Fungal biotechnology drives sustainable green industry and products. And SDG 12 says responsible consumption and production. Fungal byproducts such as biodegradable packaging and fungal leathers reduced uses, and fungal enzyme protect promotes eco-friendly industrial process. And like SDG 13, climate action, and SDG 14 and 15, life through water and life on land. You know about the life, simple brief history of microbiology. We will not discuss about this in detail. And you know about the 1965, Robert Cook reported that living cells were composed of little boxes of cells with the help of different foods. And cell theory was given in all living things are composed of cells. So this is the simple brief story of the microbiology. And this is the golden age, 1850s, 57 to 1914, has been named the golden age of the microbiology. During this period, rapid advance in moisture and rapid food have established some microbiology as a science.